All right, functions, this is our warm-up for today. So go ahead and hit pause and do this warm-up. Okay, so these should have been the answers. So 3 to the 4th is 81. The 4th root of 256 is 4, because if we think about it, 4 raised to the 4th power is 256. 5 to the 5th is 3125. And the 5th root of 32 is 2, because 2 to the 5th is 32. Okay, so we are going to put this, so we ended this yesterday in our notes. This is what we got. So now we're going to use that idea. So go ahead and hit pause and write down all of these examples, and we're going to go through them. Okay, so the square root of 36 is 6. Oh, come on. Is 6. Now remember, we have a negative right here. This negative. So this is really saying -1 times the square root of 36, which is equal to -1 times 6, which is equal to negative 6. Okay? All right, what about the 4th root of 16? That's positive 2. We have same kind of situation, so we're going to find the 4th root of 16, which is 2, times -1, so -2. Now we have a negative right here, and because this is negative and this is even, we're going to have no real solution. So when this is negative right here, and this right here is all but, now there's nothing here, this is like to the first power, this is odd to the first power, we have no real solution. The 5th root of 243 is 3, because 3 to the 5th power is 243. And then, okay, so now we have a negative underneath the radical sign, but this is odd. So it says that we are able to find at least one root. So that, and this right here, the reason why we can't have a negative like that, if I take 2, -2, let's say, and multiply that by -2 times -2 times -2, that's 4, right? We're going to get to 16, but -2 times -2 is a positive 4. Positive 4 times, and then we have to multiply that by -2 times -2. Okay, so positive 4 times -2 is -8. And then we have -8 times -2. So this is the last two that we need to multiply. We have a negative times a negative, which gives me a positive 16. So we have no way of getting to a negative number, and that's why we can't do that when this is even. So anytime you raise any number, both positive or negative, to an even power, the 4th, to the 6th, to the 20th power, you're always going to end up with a positive number, even if you start with a -1. So that's why this works. But if we look at this, we know that when it's positive, it's 3. So if we try -3, so -3 times -3 times -3 times -3 times -3. Okay, that's 5, right? 1, 2, 3, 4, 5. Yep. So we have positive 9 times positive 9, and then we have it times -3. Well, positive 9 times positive 9, that's going to be a positive 81, and we still need to multiply that by -3, and 81 times -3 is -243. So the answer to that one is going to be -3, and that's why that works. All right. So you don't need to put this in your notes, but I just wanted to kind of like show you a picture. So this is a square root function. This is just f of x is equal to the square root of x. So if we put in any value for x, we're going to always get a positive number no matter what, right? That kind of goes with you raise any number to a power, and it's always going to be a positive number. So that's why this works right here. So this is the picture versus, so this is what we call an even degree function. So it's even, meaning it's always going to be, it ends the same way it starts. So this is a cube root function or an odd function. And look, we've got negative solutions and we've got positive solutions. So if we think about that, that's why that works. Okay, now I do want you to put this in your notes. So this is saying for any real number, which we're only dealing with real numbers in this class, the square root of a squared is equal to the absolute value of a. So that's kind of like saying, if I want you to tell me the square root of x squared, I'm going to get the absolute value of x. Now, if I want you to tell me the square root of 4, that's just going to be the absolute value of 2, which is, tell me what the absolute value of 2 is. It's 2. So that's what we've been doing this whole time. So when we do that, someone in class today asked, well, why would we write 2 instead of absolute value 2 when it comes to a number? And I'm going to tell you why. X squared is an appropriate answer or solution for something, but 2 to the second power is not appropriate. You should evaluate that, and that would be 4. So that's why these two things, these are the same thing. I can evaluate the absolute value of 2, but I can't necessarily evaluate. I want the absolute value of whatever x is, whatever's going to go in this inside of it. So, all right, let's do some examples. So go ahead and write this down. Go ahead and hit pause and write this down. So the square root of 15 squared is going to be the absolute value of 15, and then we're going to evaluate that, and we're going to get 15. Now b is going to be the square root of negative 12 squared. So first we're going to find the absolute value of negative 12, and then that'll be 12, because these cancel out. So if we just say those cancel out and we're left with whatever's underneath, we need to put in those absolute value bars so that we know we get a positive. So that's why we got to remember that absolute value. Sorry, someone walked in and I got a little distracted. Okay, so now we're going to find the square root of y squared. So that is going to be, we have to do the absolute value. So the absolute value of y. Oops, why aren't you working? There we go. And that's going to be our answer. So just so you know, on the test, if you tell me that this is just y, because you know it's positive, that's fine for me. But in your homework, they're expecting to see the absolute value. And if you get it wrong, it might be because you're missing those absolute value bars. Now, if you keep getting it wrong and you put the absolute value, you might be just getting it wrong. And you can ask for help. But the absolute value is fine. So I'm not going to be a huge stickler on you giving me that answer as long as you give me a positive answer. So if you told me, like, for D, if you said that the answer was negative y, that would be wrong, right? I know that these cancel out. I know we've learned that. Oops. I know we've learned that these cancel. But again, we need to know that's going to be the absolute value of that. And the absolute value of negative y is y. So we need to make sure that we're taking that into consideration. So if you told me that it was just y, I will accept that. But again, your homework really wants you to put in those absolute value bars. They really want you to understand what's going on there. So if you have any questions, write them down, come to class, and ask them. All right, now we have some more notes. So if your n is even and positive, this right here, even, so we're looking at both this number and this number, then your answer is going to be the absolute value of a. But if it's odd, so if this number and this number is odd, then we're just going to have an answer. So when you have even indexes, when your index is even, absolute value. When your index is odd, absolute value is not necessary because you could have a negative answer. So go ahead and make sure you hit pause and get this written down. We're going to go ahead and go and do some examples, and I would like you to hit pause after that and write those down. So go ahead and write these down. Okay, so we're going to do the first one. So we want to find the fourth root of negative 5 to the fourth power. So my index is even. The power inside is even. So both are even. They have to be the same, so they undo each other. So we're going to end up with the absolute value of negative 5, which is 5. So B, both of them are odd. This is odd, and this is odd. Absolute value is not needed because those are odd. Negative 5, because n is odd. Now we've got C, and this is including our old rule that we learned yesterday, and we've got some evenness going on. So 6 and 6, and so we're going to end up with negative the absolute value of negative 3. So negative 1 times the absolute value of negative 3, which is going to be negative 3, right? Because this is 3, and then we have negative 1 times 3. So this says negative 1 times the absolute value of negative 3, that's a parenthesis, woo, which is equal to negative 1 times 3, which is equal to negative 3. Okay, so let's look at D. D is different. This is the first time we have an even index, but we have an even exponent right here, but it is different. They're different. They've been the same so far. So when they're different, we want to look at this. So this question's let's not worry about the negative sign yet. So if we just pretend it's not there for right now. We know we have to deal with it, but we can deal with it later. So what we're asking here is, what base of m to what power, or m to what m, will get me 4 times, will get me to the 8th. So one way we can do that is if I know I need to multiply m to something 4 times, right? I need to multiply it 4 times because it's to the 4th power. What do I need to do with this 8? Well, I need to break 8 up into 4 different groups, which would be 2. So because 8 divided by 4, that's grouping, right? It's 2. So then I end up with m squared. So we're going to have negative 1 times the absolute value of m squared, which is negative m squared, because our n is even. Does that make sense? So hopefully that does. Ask some questions if you have them. I know I had some questions in class. All right, 2 more. So then we're going to do the same thing. Now we have an odd index, but this number is even. So now we just have to figure x to what power multiplied 3 times. So x times x times x. So what do I need to multiply 3 different times? Or what do I need to add 3 different times so that the exponents add up to 24? Well, 24, 3. If I divide 24 by 3, I get 8, 8, 8. And 8 plus 8 is 16, is 24. So that's perfect. So we're just going to get x to the 8th power. And we're going to do the same thing for this one. So now we have even. So we have 6y to the 18th. They're even, so we have to consider that. We can break it up. This is the same thing as this right here. This and this means the same thing, y cubed to the 6th. Because if you take 18 and divide it by 6, you get y to the 3rd. So then we need the absolute value of y cubed. So just this. So make sure you get this in your notes, but to summarize, if your index is even, you need to make sure that we don't have a negative sign underneath the radical without a power or without an even power, because then we have no resolution. We need to have absolute values as our answer. And then if it's odd, we need to make sure that we evaluate it, and if our answer could be positive or negative. It doesn't matter, but it could be either. If you have any questions, please let me know. Otherwise, I will see you guys on Monday. Have a great weekend.